Welcome to the new video. This is the solution of paper 33 of winter 2021. I hope you have seen the solutions of paper 31 and 32 before this. Let's start here with question 1, where they're asking us to find the quotient and remainder when this x square, a quadratic expression, divides this quartic expression. So let's write the dividend inside and divisor outside. All right, so we need to see what should I multiply x square so that I get 2x to the power 4, and we can get 2x square. That multiplied with x square gives us 2x to the power 4. Okay, but 2x square has to multiply with the remaining 2 also, and there is minus 2x cube. There is no x cube in top, so I'm writing it under the blank space. 2 multiplied with 2x square will get plus 4x square. Alright, and now we subtract the lower one from the upper one, but not only this one, we have to change the sign of all three. So this cancels out, but this remains. This is 2x cube positive. So let me write it here because there is no space for it there. Then we have minus 4x square, and then plus 1 is still remaining. It comes down without changing sign. We change the sign of only once we got after multiplying the divisor with one of the quotients. Next, we need 2x cube. This is x squared, so we will multiply with 2x. So 2x cube and then minus 2x squared and 4x. Yeah? So this cancels. This becomes positive, this negative. So we are left with minus 2x squared minus 4x plus 1. Now again I need minus 2. So minus 2x squared here plus 2x here. And 2 times minus 2, minus 4 here. Subtract. So plus, minus, plus. This cancels out. This becomes minus 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 6x, and that is 5. So we got our remainder. This is remainder, and that is quotient. Question 2 is asking us to sketch a graph of this absolute function. So let me try to draw x and y axis. Okay, so this is x, this is y. Now I need some points. First we should focus on this inside part and look at the vertex. For vertex we should always make the content equal to 0. And that will be 2x equal to 3 and x is equal to 3 over 2. So this is the vertex of the absolute linear graph. Let's say if this is 1, this is 2, so this is the vertex. This must pass through here, okay? And then it will get reflected upwards. So for other points, we have an idea now what points we need, so we'll make a table. 1.5 is known to us. Now we will take numbers around it. So let's say some negative numbers. Let's take this as minus 1, minus 2, 1, 2, 3, and 4. I think they are enough. So I will make a table with them. Even though for a linear graph you just need 2 points so that you can join them, but I have taken so many points because of absolute there will be some turning point, and to ensure that our straight line is actually straight. Sometimes because of miscalculation we may get wrong numbers. So now let me fill up the y values by substituting these x values into this absolute. Let me show one and then others I will fasten up. So first one I am taking minus 2. So absolute 2 times minus 2 minus 3. So that becomes minus 4 minus 3. and minus 7 absolute, and when we remove absolute it becomes positive 7. So that means with minus 2 we'll have to have positive 7. So 1, 2, my scale is a little narrower here, but it's okay. So 1, 2, 3, 4, 5, 6, 7, that is there. So minus 2 here. Okay, and I know this is the vertex, and let me fill up the whole table now, and I will complete the graph also. This is the likely graph. My scale may be here or there, but this is the shape we have to draw. Let's see what the B part says. B part says solve the inequality same absolute 2x minus 3 is less than 3x plus 2. The best thing for solving this one will be, because we have a graph, let's draw the graph for 3x plus 2 also. Y equal to 3x plus 2, a new function. It has a gradient of 3 and y-intercept is 2. So y-intercept is here. Let me change the color for this. This is y-intercept, right? And the gradient is 3. That means it is, rise is 3. 3 can be written as 3 over 1, correct? Rise is 3, run is 1. So we'll go 1 here and 3 up. 1, 2, 3. That is the new point. And let me draw a line with this 2 points, and that gives us some idea what could be the answer. Here, they're wanting that 3x plus 2 should have a higher value than 2x minus 3. At x equal to minus 1, this yellow graph is lower and the orange graph is higher. That means that is not fulfilling the condition. It is condition till they cross here, the condition is same, that orange graph is above yellow graph. We want yellow graph, which is 3x plus 2, above the absolute graph, which is happening after this point of intersection, and the gradient of the yellow graph is so high that this line will never go over this yellow line. That means this is the point beyond which the 3x plus 2 is above, more than absolute 2x minus 3, and we have to find that point. Let's find that point. So for that point, what will we do? We will make this 2x minus 3, it is after bouncing up, right? This graph, this part of the graph of absolute is after it was reflected on x-axis. That means we'll have to change the sign of 2x minus 3. So let's change the sign of 2x minus 3, because this is the original graph without changing sign. So 2x minus 3. Let's do it here. So we will change the sign of 2x minus 3 and equal to, we want a point of intersection, so we'll make it equal to. So it becomes minus 2x plus 3 equal to 3x plus 2. So let's bring 3x to this side. Minus 2x minus 3x equal to 2 minus 3. Yeah. So it becomes minus 5x equal to minus 1. So x becomes minus 1 over minus 5, 0.2. Alright, so this point where they are intersecting, x is 0.2 here. So our final answer will be whenever x is greater than 0.2 or 1.5, you can write 3x plus 2 is greater than absolute 2x minus 3. This is the answer graphically. There are some algebraic way you might have been taught. You can apply that one, but I think because of the part A, this is the easiest one. Let's see question number 3 now. Alright, this is an exponential question and we have to solve the equation. So you can see here 4 to the power x is here, 4 to the power x is also here. That means we need to convert this into purely 4 to the power x so that we can go ahead. So 4x over 4 square. I can write this 4x minus 2 like this because the exponent is subtracting. That means we can divide the bases. equal to 4 to the power x minus 4 square is 16, right? So let's convert that also. 4 to the power x over 16 equal to 4 to the power x minus 16. Now, this 16 is a denominator, other two don't have denominator, and whenever you have such a situation, multiply the whole equation by the same denominator so that this 16 gets cancelled out. So when 16 multiplies with 4 to the power x divided by 16, we get just purely 4 to the power x. But this 16 multiplied with this will get 16 and then multiplied by 4 to the power x minus 16 times 16 will be 256. And now we can assume that 4 to the power x is equal to, let's say, a. So a equal to 16a minus 256. So 16 can come here. So it's a minus 16a equal to minus 256, and let's complete it here. Minus 15a equal to minus 256. So a will be minus 256 over minus 15, and both become positive and they don't simplify. Now, because a was our creation, it was not part of the question, we'll go back to what we assumed. 256 over 15. Now, to find the value of x, we must use logarithm, and we'll apply log to both sides now. Log 4 to the power x equal to log 256 over 15. Now, whenever we have an exponent, it becomes the coefficient. So, x log 4 equal to log 256 over 15. And finally, x will be log 256 over 15 divided by log 4. Let's put this in our calculator and we get our solution. By the time I do this, I would request you to subscribe to my channel and like and share this video with your friends so they get benefited, and I'm motivated to make more such videos for you. Thank you. And the answer I got from my calculator was 02.047. You can round it off to 2.05. Let's go on to the next one. Find the exact value of this definite integral. And here we can see that x and sine half x are multiplying. We can use the integration by parts. What do we have? We have an algebraic here. All right, we have a trigonometric here. That means this will be u, this will be v prime. So we know that u v prime equal, integration of that is equal to uv minus u prime v. U we have, v we need. So that means we have to integrate the trigonometric function. So let's do that. Trigonometric is sine half x. Sine half x dx. This will be v. So sine is minus cos half x is the integration of sine half x, but we have to divide by the differentiation of the angle, which will be 1 and over 2. I'm writing 2 here. So that becomes our v. So our solution is u is x, v is minus 2 cos half x. So I will write here minus, let's write minus 2x straight away. Minus 2x cos half x. This becomes uv. Now minus, we have to differentiate u, which is x, right? X is u. So differentiation of x will be 1 and u prime becomes 1. V we just got minus 2 cos, so let's make it plus now because of that minus, and let's write 2 outside cos half x. I hope you understand. U is x, v is minus 2 cos half x, u prime is 1 and v is minus 2 cos half x again. So it will be minus 2x cos half x. Half x. I didn't write it well. Okay, and that is plus 2. And cos half x, the integration will be positive sine half x divided by half. So we'll multiply again by 2. So let's multiply here again by 2. Right? Divided by half means multiplying by 2. Alright, so we got our answer in plus c. Let's apply the limits now. So minus 2x cos half x, then plus 4 sine half x plus c, and limits are 1 over 3 pi, 2 pi. Let's substitute the values now. Minus 2 pi cos pi by 2 plus 4 sine pi by 2 plus c minus minus 2 pi by 3 cos half pi by 3 will be pi by 6 plus 4 sine pi by 6 plus c. So let's clear up c first, because this will be positive, this will be negative, they're gone. 2 pi cos pi by 2 is 0, so this becomes 0, don't write it. 4 sine pi by 2 is 1, just 4, minus this 2 pi by 3 cos pi by 6 is square root 3 over 2. So this minus become positive, 2 pi by 3 and square root 3 over 2. Then this minus and this plus will become minus 4, and sine pi by 6 is half. Alright, so this is 2. 4, this 2 and this 2 cancel, plus square root 3 over 3 pi minus 2. 4 minus 2 is 2 plus square root 3 over 3 pi. That's the answer. Now question 5. Solve the equation, this trigonometric equation, sine theta equal to 3 cos 2 theta plus 2, and our answer should be between 0 and 360 degrees. For that, first we have to convert one trigonometric ratio into other. Sine theta cannot be converted into cos 2 theta easily, but cos 2 theta has an identity which has sine in it, and this is that identity. So this is what I'm going to use in this equation. So sine theta remains sine theta, but cos 2 theta becomes 1 minus 2 sine square theta plus 2. Let's bring everything to the left side. Before that, we'll have to open this. So sine theta equal to 3 minus 6 sine square theta plus 2. So when this 6 sine square theta goes to the left side, becomes positive. There is a sine theta already here, and 3 plus 2 is positive 5, but on left side it will be negative 5 equal to 0. And now we can assume sine theta equal to some alphabet, say x. Okay, so it becomes 6x squared plus x minus 5 equal to 0, and it will be easy by this method to factor this, and I will hurriedly factor this. You can use your calculators if they're capable of solving this. Otherwise you can use the quadratic formula, minus b plus minus b squared minus 4ac over 2a. But I think this will be easy to be solved by factoring, so I'm doing this. So 6x squared plus 6x minus 5x minus 5 equal to 0. Okay, so it becomes 6x minus 5 and x plus 1. So we get two solutions. 6x minus 5 equal to 0. That gives us x equal to 5 over 6 positive. And this gives us x plus 1 equal to 0 minus 1. So our domain, they are saying our solutions should be from 0 to 360 degrees. So that means we'll have to take both the answers which are originally were sine theta. This x was sine theta, so we'll go back to sine theta. So let's do it here. Sine theta is 5/6. So theta, they're asking us to find, will be sine inverse 5/6. And since it is positive, 0 to 360 degrees, sine is positive in this quadrant and this quadrant, we will put sine inverse 5 or 6 here. Second one is sine theta equal to minus 1. For that, we don't need any quadrant like this. Just draw the graph of sine theta, and sine theta graph is this. So we know this is 0, this is 360, and this at this point the value is minus 1, right? And this is the one they want. What is the angle here? It is 270. Okay, so if you put this in your calculator, most probably your calculator will give you minus 90 as answer, which is not between 0 and 360. So you can't use your calculator, use graph for minus 1 and 0. Since we have minus 1 here, so I got this answer straight away. So here we get theta equal to 270 degrees. Now this is the one where I wanted these angles, acute angles in these two quadrants, and both will be same. So sine inverse 5 over 6. Let me use my calculator to find this. By the time I do that, I would request you to subscribe to my channel, like and share this video with your friends. And I've noticed that 87% of my viewers are not subscribed. If you subscribe, it will motivate me to make more such videos, and it will benefit all of you. Thank you very much. The angle I got here was 56.4 degrees. So I will write 56.4 in both the quadrants, and now my answers start here. One answer is already with us. Theta equals to 270 degree. Let's call it theta 3. So theta 1 will be from 0. We always count from 0 to this line, which is 56.4 itself. That is the second answer. Theta 2 will be starting from 0 again, but reaching the line we drew here, which will be 180 minus 56.4, and it is 123.6 degrees. These are the three answers for the given equation. Let's move on to the next one, which is this one, and again a trigonometric equation, but rather expression in different look. I love it. So let's see what we can do here. By first expanding cos x minus 60 degrees, show that this plus cos x can be written as r cos x minus alpha. Okay, so let's expand cos x minus 60 degrees. Alright, and the identity we'll have to use will be this. Cos a minus b will be cos a cos b plus sin a sin b. This is the formula for cos a minus b, and that's what we're going to do here. Cos a is x in this case, cos b, which is 60 degrees, plus sin a sin b. Okay, since these are the proper angles ratios, so better we put their values first, otherwise they will create trouble later. Do not carry them for long. So it will be cos x, and cos 60 is half, so let me write half in front, plus sin x, and sin 60 is square root 3 over 2. This is the expansion of 2 cos x minus 60, and I did not write 2. That reminds me. That means I have to multiply this whole thing by 2. And when I multiply by 2, these two denominators will get cancelled out. The new expansion is cos x plus square root 3 sin x. Right? And then after that there was a cos x. So we can put a cos x here. That becomes 2 cos x plus square root 3 sin x. And this is what we have to convert into the format r cos x minus alpha. So what will I do? I will first expand this also, r cos x minus alpha, and I will use the same identity I used earlier to expand. So let me write that here. R remains out. Cos x minus alpha becomes cos x cos alpha plus sin x sin alpha. Okay, now since both cos x and sin x have some numbers with them, so I'll have to take this r inside. Let me expand this. R cos x cos alpha plus r sin x sin alpha, that's what it becomes. So now we can compare the two equations, the given one which was here and the one which we have to convert to. So cos x is here, cos x is here. 2 is extra here and r cos alpha is extra. So I will write r cos alpha is 2. If I want to convert this into this format, I have to see that r cos alpha is 2. Similarly, square root 3 is here, and I didn't write r or this here. R sin alpha is here. So r sin alpha equal to square root 3. Right? So now our first job is to find alpha. And have they given any condition for alpha? They have given it is between 0 and 90, and r has to be positive. These are the two conditions. So let's go back. To find alpha, we should always divide this equation on the right by the equation on the left. And the reason for that is because r and r will cancel and sine over cos will become tan. And that's why we divide this way, not the first by the second. Okay. So it becomes tan alpha. R is cancelled out, square root 3 over 2, and alpha becomes tan inverse square root 3 over 2. Since 0 to 90 is the only quadrant we can use, that means the angle has to be only this one. So we can use our calculator again to find tan inverse square root 3 over 2. And I got it as 40.893. So for 3 significant figures, I will write 40.9 degrees. Let's see what is the condition they have given. 2 decimal places, sorry. So we'll have to write 40.89 degrees. Now, for finding r, the condition is that it has to be more than 0. And also, they're saying the exact value. If this exact value was not there, we would just put this alpha into, say, this equation, and we would get the value of r. However, for exact value, we'll have to sweat it out. How? Square this equation. It will become r square cos square alpha equal to 4. So I square the left side, right side, both of them. Similarly, I'll square the one which was the second equation, r square sine square alpha equal to square root 3 square. Square and square root 3 will cancel here. So here we will add the left side to the left side and right side to the right side. What do we get here? Both of them have r square, so I am taking that as common, and we will be left with cos square alpha plus sine square alpha from here. Here we have 4 and this becomes 3. 4 plus 3 is 7. Cos square alpha and sine square alpha is 1, so no need to write that anymore. R square is 7, square root both sides. R is equal to positive or negative square root 7. But remember, they've said R is a positive number. That means we cannot use the negative one. R is square root 7 only. Let's see what is the other part of this question, which is here. Hence, find the value of x in the interval 0 to 360 degrees. Okay, x, okay, not alpha this time, for which this one has the least possible value. So in place of this expression, we will write the new format we had. We had r cos x minus alpha. This was the format, right? R we got was square root 7 cos x minus 40.9 degrees. All right, let's leave it for the time being. Okay, let's focus on only a cos graph. If y equal to cos x, this is the graph, it looks like this. All right, so at what angle it takes the least value? It takes at 180 degree, correct? Now, what is the maximum value if I put a square root 7 in front? That becomes the amplitude. So this becomes the maximum value and this becomes the minimum value. But they are not asking what is the least value, right? Yeah, they're not asking. They're asking where does it take the least value. So if x was there, 180 was the position where it took the least value. But now the angle is x minus 40.9 degrees. That means your graph has been shifted to the right this way by 40.9 degrees. So your answer will be 40.9 to the other side. Sorry, not 140, 40.9, and which is 180 plus 40.9, which is 220.9. This should be the answer, but we can't just say it and do it. We have to show it on paper. So we will say the least value of cos x is at, and we will not write it here, okay, 180 degrees, right? But when x is not x, it is x minus 40.89 degrees, the least value. In that case, x minus 40.89 degrees becomes 180 degrees, and x will be 180 plus 40.89 degrees, which is 220.89 degrees. Do we need to? Okay, they've not given how many decimal places, so we can round it off to 220.9 degrees. This is the place where it takes its least value. Move on to question number 7. The equation of a curve is this, all right? Show that dy over dx is this expression. Now, the problem here is that x and y are mixed up, right? It's not y equal to something and we straight away find differentiation. So we'll have to use implicit differentiation in this one. So how do we do that? We differentiate it normally, but wherever y is involved, we add dy over dx as a suffix. So let's start with the ln x plus y. Okay, I'm not going to the right side, only this one I'm going to differentiate first. If it was, say, ln x, what would be the differentiation of ln x? It would be 1 over x, and then whatever is inside ln differentiation of that, right? Same thing we will do here. So the differentiation, let me write here, d over dx, right, will be, with respect to x we are differentiating, 1 over x plus y, not 1 over x, because it was x. In place of x plus y, we will write 1 over x plus y multiplied by the differentiation of what is here, So differentiation of x is 1 and differentiation of y is also 1, but since y is involved, dy over dx is written. Right? I will look at this again later. Let's go to the right part, x minus 2y. This is easier. X, the differentiation of x is 1. Minus 2 is a constant, so don't touch it. Just look at y. Differentiation of y is 1. And because it's y, dy over dx. And now write both of them together according to the placement in the equation. So left side was differentiated like this. So 1 over x plus y, 1 plus dy over dx. I'm not writing this one, okay? No need. Equal to 1 minus 2 dy over dx. Now, our next aim should be to isolate dy over dx, okay? And to isolate this one, we'll have to open this bracket first. So 1 over x plus y. When 1 multiplies with this, 1 over x plus y. Again, 1 over x plus y dy over dx. It multiplies with dy over dx also. And let's bring this also, or let's write it as it is. Since dy dx is liberated from the bracket, so let's bring this dy dx with it so that we can combine them. And this 1 over x plus y will come with this 1. So let me write the right side first. 1 remains where it is, but 1 over x plus y comes here from here. Now, this was already here, so let me write it. 1 over x plus y dy over dx and plus 2 dy over dx comes from the right side, this one. Now, we have to isolate dy over dx. That means we will have to make it a suffix of a bracket. And what is inside the bracket? 1 over x plus y, this one, plus 2. Equal to 1 minus 1 over x plus y. Now, both sides we have a number and we have 1 over x plus y. So let's give this also the same denominator so that they can be merged. So I can't give it free of cost. I have to compensate it by multiplying the numerator also. Similarly here, x plus y given the denominator, but x plus y has to be the numerator also. And let's make them simple now. It becomes 1 plus 2x plus y divided by x plus y dy over dx, and this becomes x plus y minus 1 over x plus y. Since both of them have x plus y denominator, they can cancel out. They're multiplying, they can cancel out. We can do this. And dy over dx remains here. And by cross multiplication, this one goes and takes the place of denominator here. So x plus y minus 1 remains numerator, but 1 plus 2x plus y becomes denominator. Is it the expression they wanted us to write? And exactly, x plus y minus 1. Only the placement of 2x plus y plus 1 is different, but in addition, commutative property, you can write anything anywhere. That's good. We got it. There's one more part to this. Find the coordinates of the point on the curve where the tangent is parallel to x-axis. Okay, so this is y-axis, this is x-axis, and parallel to x-axis means a horizontal line. Tangent is a horizontal line, and that means they are talking about a stationary point. Only at the stationary point you have a tangent which is a horizontal line. The gradient of a tangent at that point is 0. So basically dy over dx, which is the gradient of tangent, should be equal to 0. That means this should be equal to 0. X plus y minus 1 over 1 plus 2x plus y should be equal to 0 to get that point. Okay. Now by cross multiplication again, this denominator goes and multiplies with 0 and few vanishes. We are left with x plus y minus 1 equal to 0. And let's isolate x in this case. X equal to minus y plus 1. Right? Now, this is one relationship which will give us the value. But what is the other relationship? Which is the main equation. Ln x plus y equal to x minus 2y. Let me write here. Ln x plus y equal to x minus 2y. So let's substitute this into this equation now. Ln, in place of x I will write minus y plus 1, and plus y was already here, this one, equal to x minus 2y. So minus y and plus y cancel. Ln 1 is left, and ln 1 is always 0. X minus 2y. And this, we got another equation. Let's substitute back this x value in this one. Is that going to help us? Let's see. 0 equal to minus y plus 1 minus 2y. So minus y minus 2y is minus 3y. 1 minus 3y equal to 0. So 3y equal to 1 and y is 1 over 3. And now we can get x. X equal to minus y, which is minus 3, 1 over 3 now, plus 1. X equal to 2/3. So we got the coordinates 2/3 and 1/3. I think that was the requirement. Find the coordinates of the point. We got them. Question 8 looks dangerous and complicated, but if we keep our cool, I think we can do it very easily. So let's shift the drawing to some other side and do it here. In the diagram OABCD is a pyramid. We can see that with vertex at D. All right, the horizontal base OABC is a square of side 4 units. So keep in mind, this is 4, this is 4, this is 4, and this is 4 units. Okay, units means 4i, 4j, 4k, those kind of units. Okay, if we want to talk in terms of vectors. All right. The edge OD is a vertical, and OD is also 4. That means this is 4k in this direction, right? The unit vectors I, j, k parallel to OA, OC, and OD respectively. We have seen that. The midpoint of AB is M. Okay, this is the midpoint. That is from here to here, it will be 2. From here to here, it will be 2. I'm trying to make a picture in my mind, okay? And then point N on CD is such that the DN, D to N, okay, equal to 3 times NC. So if this is 1, this is 3. In other words, we can say that NC is 1/4 of DC, or DN is 3/4 of DC. Keep these facts in your mind and we will be able to do it. Let me clean the picture now. I have the understanding of the facts, so let's not keep these numbers here. All right. Find a vector equation for the line through MN. Let me draw a line through MN. They have already done that, but let me do this myself also. This is the line they're saying. Since their line is stopping at M and starting at N, we can go beyond that also. So not to complicate this, they have stopped. Otherwise, this line can go endlessly. All right. They want a vector equation. So vector equation can be written in component form or column notation or IJK algebraic notation. So let me show you what I mean. Let me prefer algebraic. Okay. So you will have a point plus a parameter multiplied by the vector direction of that particular vector. So let's say the vector is MN, this one. So head is at N and tail is at M, and I'll take this vector, right? And I need a point. Let me take M because M is easier to find. Whatever are the coordinates of this point become this point, right? So let's find the coordinates of this one first in IJK format. So we know that OM is the position vector, this OM, and that will become the coordinate. Whatever is OM vector, that becomes the coordinates of this point. What are the coordinates? We go in this direction, which is 4i, all right? So x coordinate becomes 4. Then in y direction, we're going 2j. So 2 and 0. There is no k. It is at on the floor of the pyramid, the base of the pyramid. So 4, 2, 0 are the coordinates of M. 4, 2, 0. So the point part becomes 4i plus 2j and no k. So I'm not writing the k. Now I have to choose a parameter. Let's say parameter is a. Okay. Now I need a vector, and vector is mn. So I know the coordinates of m, basically OM vector I know already. OM is 4i plus 2j plus 0k. This is OM. The only problem left is somehow if I can find ON, right? And that will complete our equation and vector. So ON, I want to go to ON. Can I go this way? I go this OC. Let me write somewhere. ON equal to OC plus CN. Yeah, CN, this one. That's how I will get ON, right? So CN is not known to us. What is CN, right? In place of CN, can I write it as, we talked about it, 1/4 of CD. Yeah, CN is in same direction of CD and it is 1/4 of it. And CD vector we can express in terms of I and J. So let me write here again, ON will become OC, which is 4J, yeah, 4J, plus 1/4 of CD. For CD, what will I do? I'll go to this direction first and reach to O, CO, right, which is minus 4J. And then I will go to D, OD, which is plus 4K. Understand? Because I did not have CN, so I found CD by CO plus OD, and 1/4 of that is CN, and that's what is giving me ON. So let me write ON here. It becomes 4J, and now 1/4 of minus 4J will be minus J. 1/4 of 4K will be K. So we get 3J plus K. That is ON. And now we needed a vector MN for this. MN is because the tail is at M and head is at N. Head minus tail, position vector of N minus position vector of M will give us MN. And we just got ON, 3J plus K. And we had OM already, 4i. So let me add minus, and I will change the sign of all of them. 4i minus 2j and minus 0k. There is no need to write that. So what do we have? We have here minus 4i and 3j minus 2j is plus j and k is alone. That's it. We got the vector also, and we will write it here. Let me write here. Minus 4i plus j plus k. I needed a point. I already had that. I needed a vector. I found it. And this, let's put r equal to in front of this. If I put r equal to in front of this, this becomes the equation of the line through M and N. There is another part to it, and which is this. Show that the length of the perpendicular from O to MN is this. So let's go back to our drawing. It will be very complicated here, so let me draw it there only, and we'll need this equation. If this is the line MN and this is the perpendicular from origin to this line. Let's call this point as x, and its coordinates as p, q, r. All right. So the position vector OX will be pi plus qj plus rk, right? And now we know that the line MN and OX are having a 90-degree angle. That means vector MN and OX, their dot product will be 0. So first we know that X is lying on the line MN, and MN has this equation. Can I say that P coordinate will be 4i, this one I'm talking about, this 4i plus, I'm not writing I, okay, because the coordinate I'm talking about this time, not the vector. And here we have minus 4i. So we can write 4 minus 4a. That is the P coordinate, this one. Q will be 2j, 2, and there is j here, plus j, a plus 1a. Alright, R will be, there is no k here, so we'll just write 1k, so 1a. So if we find a, somehow we can find PQR, and that will give us the vector OX, and if I find the magnitude of OX, that will be the perpendicular distance from origin to MN. That's the length they want, right? So we know that they are having a dot product of 0, so MN was already with us. It was minus 4i plus j plus k. This one. This is vector MN in this equation. Dot OX. OX will be P, we have written the Pi, Qj, Rk, but I will not use P, Q and R now. I will use their values in terms of A. So 4 minus 4ai plus 2 plus a, j, and a, k. So I used the parametric equation in place of this because P, Q, R are 3 variables, but A is just 1 variable. That's why I used it, and that is equal to 0, the dot product. So I multiplies with I. So minus 4 multiplies with 4 minus 4a, 1 multiplies with 2 plus a, 1 multiplies with just a, that is equal to 0. We don't write I, j, k in dot products, okay? So it becomes minus 16 plus 16a plus 2 plus a equal to 0. 16a plus a, 18a equal to minus 16 plus 2, minus 14. And minus 14 goes to the right side, becomes positive 14. A is equal to 14 over 18, that is 7 over 9. So now we can write P will be 4 minus 4 times 7 over 9. What will that be? 28 over 9. 36 minus 28, 8 over 9. I'm doing it mentally. You can just put this in a calculator, you'll get it. Okay. Q equal to 2 plus 7 over 9. That will be 25 over 9. R equal to 1a, just 7 over 9. So that's the coordinates of x, and OX becomes on this basis 8 over 9i plus 25 over 9j plus 7 over 9k, and we wanted perpendicular distance, which is the magnitude of OX. The magnitude of OX will be 8 over 9 square plus 25 over 9 square plus 7 over 9 square. All right. Is it giving us the right one? Let's see. Square root 64 over 81, 625 over 81 plus 49 over 81. Since 81 is common, we can take that as 1 and add the top 3. So it will be 9, 5, 14 plus 4, 18, 3 plus 4, 7 plus 6, 13, and 1. 738 over 81, and that is square root. 738 is 82 times 9, and we have 81 as denominator. 9 and 81 cancel out 9. And when this 9 comes out, it becomes 1 over 3, and we are left with 82 inside, and this is what was the required number. Question 9 is giving us a function and asking us to find the x coordinate of the stationary point. The stationary point, that means it has only one stationary point, and we have to find its x coordinate. So for stationary point, f prime x or dy over dx should be equal to 0. Why? Because at stationary point the curve turns back and the tangent on that turning point is a horizontal line, and the gradient of tangent is 0, and dy over dx or f prime x actually represent the gradient of the tangent. That's why we make it equal to 0. So let's find dy over dx for the given function. So before I differentiate this, let me change it to 9 minus x to the power minus 1 and x to the power minus half, so that I can use product rule and carry out this differentiation easily. I could have used quotient rule also. That will be a little complicated, so let's do this one. So product rule, according to this, we differentiate the first one first. So 9 minus x minus power 1, we differentiate this one, but we don't touch the other multiple. In next one, we keep the first one as it is, but we differentiate the second multiple. So let's differentiate 9 minus x to the power minus 1. Minus 1 becomes the coefficient. Because it's power of a function, the exponent goes down by 1, becomes minus 2, and multiplied further by the differentiation of what is inside. 9 minus x, 9's differentiation is 0, minus x's differentiation is minus 1. X to the power minus half was already here, plus, okay, we don't touch this, so 9 minus x to the power minus 1, but we will differentiate x to the power minus half. So again, minus half comes in front, the power goes down by 1, so minus half minus 1 will be minus 3 over 2, and further we multiply by the base, which is just x, so 1, you don't write it or write it, doesn't matter. Alright, let's see, because I have to make it equal to 0, yeah, and we can't do it straightforwardly. So let's do what? Let's factor this. That will be better. We should always factor this. Some of you may like that this one goes to the right side and then we cross multiply and cancel out things. But in that case, we may lose some answer. Okay, though they're saying there is only one stationary point. That's not the risk, but why to take it? All right, this minus 1 and this minus 1 make it positive, right? Now, what is the common between this and this? The common is always the one with smaller exponent. Minus 2 is smaller exponent. So we will take that as common. So let's take 9 minus x to the power minus 2 as common. In x to the power minus half and x to the power minus 3 over 2, what is smaller? Minus 3 over 2 is smaller, so we'll take it common. Alright, so now what is left? This was already positive 1, so we don't look at this. This is already out, so out of minus 3 over 2, minus half is more. So let's see what is left. Minus half minus minus 3 over 2, which will be 1. So that means we are left with x here, x to the power 1. Now plus, and there is minus half here, this one, right? This minus half is multiplying. So minus half, so minus. 9 minus x to the power minus 1 is more than this minus 2. So we'll get 9 minus x power 1 remaining from here. Minus half not taken common, so it has to be outside here, minus half. Okay, minus 3 over 2 is out. 1 doesn't make any sense, so leave it. Alright, so now let's make the exponents positive. So this minus 2, I'll make it 1 over 9 minus x square. This one, I'll make 1 over x to the power 3 over 2. And this one, let's make it 2x over 2 so that I can combine the two. Yeah, both of them will have 2 as a denominator. So let me put 2 down. 2x minus 9 plus x. Okay, so equal to 0. Now we have 3 factors and we'll make them one by one equal to 0. So let's make this one equal to 0. 1 over 9 minus x square equal to 0. This square goes multiplied with 0. It gives us 1 equal to 0, which is a wrong statement. That means this did not give us any answer. 1 over x to the power 3 over 2 is equal to 0. Same thing happens here. 1 equal to 0. No. And this one must give us an x coordinate for a stationary point. 2x plus x. 3x minus 9 over 2 equal to 0. 2 multiplied with 0 again. 3x minus 9 equal to 0. And yes, 3x equal to 9. X equal to 9 over 3, and which is 3. This is the x coordinate of the stationary point, and that's what they're asking. Okay, let's see B part. Using the substitution u equal to square root x, show that the definite integral is equal to 1 over 3 ln 5. Okay, so first of all, what was fx? It was 0 to 4, this one, and what was it? 1 over 9 minus x square root x and dx. This is what we have to prove, that it is equal to 1 over 3 ln 5. Okay, so square root x is equal to u. That means, because we have an x also here, so we'll have to square both sides. U square equal to square of square root x will be x. And we have to change the limits also. So when x is 0, this 0, what will be y? What will be u rather? U equal to square root 0 equal to 0. Alright, so limit remains 0 for the lower end. When x is 4, the upper limit, u equal to square root 4, and which will be equal to plus minus square root 2. But since this limit is always more than this limit, that means it has to be plus 2, not minus 2, so minus ignored. This will be 2. What else? We have to substitute dx also. So let's differentiate this particular relationship. Du over dx will be square root x can be written as x power half. So when differentiate this, we get this one, half x to the power half minus 1, which is minus half. So that is basically 1 over 2 square root x. Alright, now let's substitute the things. First of all, let's substitute the dx because it is not matching. We have just square root x, we don't have any 2 here. So let's put a 2 here forcibly, and we'll have to compensate this, so we'll put a 2 outside. Okay, and now this part becomes du because that's what it is. If this dx goes and multiplies here, it becomes du equal to 1 over 2 square root x dx, and that's what it is, right? So du 1 over 9 minus, okay, x is u square, so u square here. I didn't write 2 here, so this we should not miss. All right, so I will ignore this 2, the limit 0 and 2. I will just focus on the integration and we'll go back to these numbers later. Okay, so I can write this 9 minus u square as 1 over 3 plus u and 3 minus u, isn't it? Some of you may make this mistake. We have an integration of 1 over 1 plus x square dx equal to tan inverse x. But this is plus here, and here we have minus. So we don't have any such connection with tan inverse in this one. So we have to factor the denominator because it is a difference of perfect squares, and that's what I've done here. And now I will use what? Partial fraction. So 1 over 3 plus u, 3 minus u is equal to a over 3 plus u and b over 3 minus u. Okay, so if I compare the numerators now, because denominators will be same if I take the LCMs by multiplying these two, 1 will be equal to a will multiply with the other denominator 3 minus u plus b 3 plus u. All right, and to evaluate a and b, we will assume now let u be equal to this u equal to 3, so that 3 minus 3 it becomes 0. So what do we get? 1 equal to 0 and b will be 3 plus 3. So 1 equal to 6b, and that gives us b equal to 1 over 6. Let's do the same thing with the other. Let u equal to this time minus 3, so that this becomes 0. So 1 equal to a 3 minus minus 3, and I'm not adding b because that is going to become 0. 3 minus 3 is 0. So it becomes 1 equal to 6a, and a is also 1 over 6. So our now this particular integration put back the things we excluded earlier. Let's put them back. What was that? Limits were 0 to 2. So 0 to 2, and there is a 2 in front. We got a equal to 1 over 6. Let me write 2 over 6 here so that it does not mix up with the integration. 3 plus u du plus again 0 to 2, 2 over 6, and because b is also 1 over 6, right? So 2 over 6, 1 over 3 minus u du. And let's complete this thing down here. Okay, so 1 over 3 plus u. The integration, okay, 2 over 6, we can substitute, no, we can simplify it. 1 over 3, right? 2 over 6 is 1 over 3. Okay, and this will also be 1 over 3. So let's take it common from both of them. And 1 over 3 plus u will be ln 3 plus u, because if there's a linear denominator, we can do that, divided by the differentiation of 3 plus u, which is 1. Okay, what do we get here? Plus ln 3 minus u this time. And differentiation of 3 minus u will be minus 1, isn't it? 3 minus u, 3 differentiation is 0, minus u is minus 1. Plus c, and we have limits from 0 to 2. All right, so let's substitute the values and hopefully we'll get our answer. So it will be 1 over 3 rather. 1 over 3, okay, ln 3 plus u over 3 minus u, isn't it? Because of this minus, this will become negative, and 2 logs, if they are subtracting, we just divide their contents. So it will be 3 plus u divided by 3 minus u plus c. 1 over 3 ln 3 plus 2 over 3 minus 2. and there is plus c also, and then we'll subtract len 3 plus 0 over 3 minus 0, and this time minus c. Plus c and minus c cancel out, and we are left with what? 1 over 3. 3 plus 2 is 5, so len 5 over 3 minus 2, 1. Okay, minus len 3 plus 0 is 3, 3 minus 0 is 3. Okay, 3 over 3 is 1, so len 1 is 0. This one is gone. Only thing left is this one now, which is 1 over 3 len 5, and hopefully this is what they wanted us to show. Yes, 1 over 3 len 5. Question 10. A large plantation of area 20 kilometers square, okay, is infected with plant disease. At time t years, the area infected is x kilometers square, and the rate of increase of x, okay, dx over dt is proportional to the ratio, ratio means we divide, of the area infected, which is x, to the area not yet infected. So total is 20, so the area not infected in that case will be 20 minus x. Good. Show that x and t satisfy the differential equation. So we will convert it to equation first. Dx over dt equal to kx over 20 minus x, which matches with this equation. Only thing is that we have to show that k is 19. So we can take the help of this situation. Dx over dt is 1. So in place of dx over dt, I'll write 1. And what else do we need? X. X is 1. So k times 1 over 20 minus 1. T equal to 0 is not needed in this, so we will not use it. So cross multiply here. We get what? 20 minus 1 equal to k. And yeah, k is 19. 20 minus 1. So it becomes dx over dt equal to 19x over 20 minus x. We showed it. Let's go to the next part. Solve the differential equation and show that when t is equal to 1, the value x satisfies the equation, this one. Alright, we have to solve the equation. The equation was dx over dt equal to 19x over 20 minus x, right? So to solve a differential equation, we should have dx with x's and dt with t if there is any, and there is no t here, so dt will be alone. So let me take this x down here. So dx remains, it has to be a numerator, okay? Dx and dt, both of them should have been a numerator, so dx stays here and dt comes to the other side and becomes a numerator. So this dt is gone. I'll bring this x here, and 20 minus x also goes and multiplies with dx. So it will be 20 minus x here. What is left? 19 is left here. 19, I could have written 19 here also, but it's better to keep it with dt because dt is poor guy alone. So let's keep 19 with dt. Alright, so we'll integrate now. Since our dt and dx are numerators, we can integrate this now. So it becomes 20 minus x over x dx equal to 19 outside and dt. And let's try to finish it here. So can I separate this one as 20 outside, 1 over x dx minus x over x dx. I separated numerators because there is only one denominator, so I can do that. Equal to, and I can straight away integrate this 19t. And let's write plus c also. Okay, 1 over x, the integration of 1 over x is 20 len x. And the minus x and x cancel. So what is the integration of 1? Is just x. Equal to 19t plus c. Now we have to evaluate c, and now that situation will be useful here to find c. They said when t is 0, x is 1, and this combination we can use here to find c. When t is 0, so 19 times 0, let me write the relation here, otherwise you may not understand why we are doing this. When t is 0, x is 1. So 19 times 0 plus c equal to x is 1, so minus 1, 20 ln 1. Ln 1 is 0, this becomes 0. Minus 1 equal to, this is also 0, c is minus 1. So what does our equation become now? Our equation was this one, so 20 ln x minus x equal to 19t minus 1 now, okay? But they want this format. X has to be alone and it is to be e to the power. That means if I isolate this x, this ln will cause the other part to become e to the power. And that's what I'm going to do now. I'm going to isolate ln x first. So ln x, 20 ln x equal to, this x go to the other side, so 19t minus 1 plus x, and they have given the value of t in the question. T is equal to 1, yeah, and that's what I'm going to do. So 19 times 1 will be 19 and 19 minus 1 will be 18. So 20 ln x equal to 18 plus x when t is 1. Okay, can we do something? Yes, we can. Ln x equal to 18 plus x over 20, right? If we divide both sides by 20, this 20 goes and we are left with this one. And now we can isolate this x. X equal to e to the power 18 plus x over 20. Let's finish off here because I think it is not matching yet. It won't, yes, 0.9 plus. So we have to separate again these two. The numerators are 2, denominator is 1, we can separate them. X equal to e to the power 18 over 20 plus 1 over 20x, and which is what they want, e to the power 0.9 plus 0.05x. Got it. C part. Use an iterative formula based on part B with an initial value of 2. So x1 is 2, that's what we have to use, and first we'll convert the formula we got into iterative formula, this one. So the one which is isolated becomes xn plus 1, and the one on the right side is xn. So e to the power 0.9 plus 0.05 xn. This is the iterative formula we'll use, and that will give us hopefully the answer for value of x. And they're saying start with 2. So x1 is 2. So what happens? x2 equal to e to the power 0.9 plus 0.05, and they're saying start with 2. Let me put this in my calculator and get the value of this. By the time I do this, I would request you to subscribe to my channel. I've seen that 87% of my viewers are not subscribed to my channel. Please subscribe and like and share this video, share with your friends and let them also get benefited. And I try to be as detailed as possible regarding any solution. So they will get benefited and I will be motivated to make more such videos. Thank you very much. So when I use my calculator, I got 2.718. Actually, it is E. Okay, but they're saying we have to use 4 decimal places. So 28 will be 3. Okay, this is x2, and now we'll keep on repeating this unless we achieve something. What? I will let you later. Let me keep on doing this. Plus 0.05, and now x2 will be used, which is this 2.7183. Using calculator, I get 2.8177. Okay, x4 e to power 0.9 plus 0.05, 2.8177. We get 2.8303. Okay, x5 equal to e to the power 0.9 plus 0.05 2.8303, and in this case we get 2.8335, and now I stop. Why? Because they said x correct to two decimal places, and if I round this one as two decimal places, this will be 2.72. This is 2.82. This will be 2.83, and this is also 2.83. The moment two consecutive numbers are exactly same, rounded off to the number of places they have mentioned, we stop, and this becomes our answer. Our answer is 2.83. That is the value of x. This is another part. Calculate the value of t at which the entire plantation becomes infected. So we'll go back to our original equation, which was not e to the power, which was this one. We'll use this equation with this one. Why? Because we got t equal to 1, then we got this expression, so we can't use this. We will use this when t is unknown. So let me copy this and go back to that place. Here we are. So let's write it 20 ln 20, because x is 20 now, and this will be one thing, minus 20 equal to 19t minus 1. So 20 ln 20, let me put it separate, minus 20 and plus 1 will make it minus 19 equal to 19t, and we'll divide both sides by 19 so that we isolate t here, and if I plug in the whole thing in our calculator, I should get the answer. Let me do that and let you know the solution. 20 ln 20 minus 19 by 19. It gives me 2.15, and years was the unit. The complex number minus 3 plus I is denoted by u. Okay, express u in the form of r e to the power I theta. R is greater than 0, positive, and theta is between minus pi and pi, giving the exact values of r and theta. So first let's visualize that complex number. Minus square root 3, suppose it is here in a real axis, and on imaginary axis we have I, suppose here. So this becomes our u with reference to origin. So let's find the modulus, which is r. R is the modulus of u, which will be square root minus square root 3 square plus 1 square, which will be 3 plus 1 4 square root, and that's equal to 2. So r is 2, positive, negative ignored. What about the argument? Theta. This will be theta. Okay, always starts from this half line and goes counterclockwise to this line. So it is difficult to find this angle, so it's better we find this angle, this one, and we subtract it from positive pi. And this angle, let's call this alpha. So alpha plus theta equal to pi. So alpha will be tan inverse. What is the height? This is 1 over square root 3. That is pi by 6. Yeah, pi by 6. So now theta will be pi minus alpha, which is pi by 6 now. So theta is 5 pi by 6. So our argument is 5 pi by 6, which is less than pi, and we can write now it equal to r. The form is r e to the power I theta it will become u is 2, which is r e to the power I 5 pi by 6. Next part says, hence show that u to the power 6 is real and state its value. Hence means we have to use the format we got just now. U to the power 6 will be 2 e to the power I 5 pi by 6 to the power 6, right? So if I open this, it becomes 2 to the power 6 times e to the power I 5 pi over 6 times 6. Okay, it's not this to the power 6. It is when exponents are 1 over each other, they multiply. 6 and 6 cancel. So we are left with 2 to the power 6 will be 64 e to the power I 5 pi. If we use a calculator, 64 e to the power I 5 pi, put that in calculator, it gives you -1. Answer will be -64. If your calculator shows data error or does not accept this one, alternately you can do this. 64 and convert this into cos 5 pi minus I sine 5 pi format. This is 0, 5 cos sine pi is 0, this becomes 0, and cos 5 pi is -1. 64 times -1, again -64. Okay, next part. On a sketch of an Argand diagram, shade the regions whose points represent the complex number z satisfying the inequalities. These. Okay, so let me draw an Argand diagram first and try to draw that here. So hopefully it will be positive. Okay, the argument of z minus u. That means u is the reference point. This u is the reference point, and we know that it was minus square root 3 here and 1 here. This was u. So the argument starts from the half line of u, a horizontal line from u towards right. From here we will show that it is between 0 and 1 over 4 pi. So this is 0 and 1 over 4 pi will be somewhere here. This is the argument 1 over 4 pi. So we have to shade between these two arguments. Okay, but I'm not shading because there is one more condition. Then I will shade when it is meeting that condition as well. So this is imaginary, this is real, this was 1, that was minus square root 3. Alright, since this is pi by 4, this is whatever is this distance will be this distance, and this distance we know is square root 3. So this will also be square root 3. Just keep in mind, okay, maybe it will be needed later. Okay, next, and the real part of z is less than and equal to 2. So real part is this axis. So say 1 is here, 2 is here. So your real part is less than this 2. So I will draw a vertical line at 2. So it's like this, and less than 2 means this area. Less than 2 is this whole area is less than 2. So if I shade this one and the one I shaded earlier, what is the common area between the two? Common area is this triangle. And that's the shaded area we have to show, this triangle. And finally, what is that? Find the greatest value of modulus of z. Z is the unknown which is there in this shaded area. For points in the shaded region, given that give your answer correct to 3 significant figures. Okay, so greatest modulus of z. So I can write this as z with reference to 0. That means I want a distance from origin. Let me draw a line. which is the greatest in this shaded area. This is a very small line. Small and even smaller is small, not that big, becomes bigger, and it becomes biggest at the vertex. This vertex of the triangle. This red color is the greatest distance that we have to find out. Okay, so let's try to do it mathematically. We know that this distance is 2, isn't it? And this distance, we know this one is 1, right? And this one from here to here will, because this is 45 degrees, pi by 4, this distance will be exactly same as the horizontal distance, because tan 45 degrees is 1. That means adjacent and opposite are equal, right? And this fact we will use. Let me clean it a little bit. What is the distance here? This is square root 3 and this is 2. So this will be 2 plus square root 3 on top, right? So but we wanted this length as well, this one. So let me redraw that triangle again. That triangle has this side as 2 and this side now 2 plus square root 3 plus 1. The height of this one is added. So it will become 3 plus square root 3, and now we can find the hypotenuse. That's what we want here, the red color. And that will be 2 square plus 3 plus square root 3 square, and square root of that will give us our answer. And my answer is, I got 5.137, and which can be written as 5.14.